Super glad to be here. My name is Zenan Chen. I also go by Alan. I am currently a final year PhD student at the University of Minnesota. So today I'm presenting my job work with my mathematician Chen on the large language models in creative work. So in, let's see if that worked. Yeah, so let me just continue, right? So in early 2023, OpenAI first launched their API. Actually, let me refresh the web page. Sorry about that. There we go. So, let's go back one slide. Right, so with the release of the API from the ChatGPT, there has been a lot of interest in building LLM-based tools in a lot of different applications. For example, here I built a universal tool that allows you to harness the power of LLMs anywhere on your computer. Here I just asked it to write an email for me, and instantly ChatGPT outputs a very professional and full-blown email for me. So it's not just individuals who are very interested in harnessing the power of large language models. All these companies of all sizes, from Coca-Cola to small businesses like the sellers of eBay, are integrating large language models in their daily business operations. So as scholars and practitioners are starting to explore the capabilities of large language models, it has become clear that there are two distinct modalities of utilizing these large language models. So in one way, we can use large language models to directly generate the content that we want. So it's similar to how we hire a ghostwriter who does the work for us, where we give high-level instructions. Another modality is known as the sounding board modality, where we do not actually ask the LLM to do the job for us, but rather to ask it for feedback after we have done the work. So one of the unique capabilities of large language models is its ability to understand natural language and output astonishingly coherent and high-quality outputs. And therefore, large language models has been used in a host of creative tasks, such as writing songs, writing poems, or even writing ad copies, which are the tasks that were thought to be quite impossible to be tackled by the previous generations of machine learning models or AIs. With that being said, there's little that we know about how large language models can interact with humans and affect humans' behavior and performance. And in particular, there are several super classical effects that has been found in the human-AI interaction literature. So for one, there is a bias called the algorithm aversion, where there is a tendency for humans to distrust AI, even though AI is objectively better or correct. So this effect is found to be more pronounced for experts who are more confident in their own capabilities. But for non-experts who are less knowledgeable in their own domains, they may actually rely more on AI and therefore benefit from the usage of AI. But on the flip side, when humans do trust the outputs from AI, the anchoring effects can come into play, which is a cognitive bias where the human's subsequent behavior is anchored by the AI's outputs. So this effect has been found to be universal in the decision-making context, but recently people also found that this is also true in the creative process. And interestingly, this effect is found to be smaller for experts. So these competing different perspectives of how non-experts and experts should utilize AI, should utilize large language models in creative work. There is no clear guideline how they should utilize large language models. Therefore, we set out to answer the following two basic questions. First, which human large language models collaboration modality works better for creative work, and for whom? So there have been some early attempts in studying the effects of large language models on human productivity. some earlier work has found that large language models can increase the speed of completing, relatively routine or standard tasks, such as report writing, customer question answering, and furthermore improve the quality of human outputs. And they also found that inexperienced worker actually benefits more from the usage of large language models. But these studies have not looked at how humans engage with large language models, and their studies do not tackle more creative kind of tasks such as songwriting, or ad copywriting. So we set out to answer our research questions using a control experiment. We choose the ad copywriting task as our creative context. So advertising is a humongous industry that was $180 billion in 2022 in the United States alone. And there has been a large language model-based applications has been super popular in this area in which people use it to generate ad copies. For example, these are the two startups that has gathered $10 billion in the first quarter of 2023. So given the significant implication in business outcomes, we choose this as our creative task. And in addition, we also want to have a more objective view of the output quality. So past works has been relying primarily on human readers to gauge the output quality of creative, open-ended outputs. Here, we want a more direct measure by sending these ads out to the public and see how well they fare in terms of generating ad clicks in the real world. So we recruited two mutually exclusive pools of participants on Prolific. So the expert group were consisting of the participants whose occupations were coded with marketing and sales, whereas the non-expert group were participants who has unrelated occupations such as finance or architecture. So in the end, we have 355 participants in the whole experiment. And we have 3 AI conditions. The control group does not have access to the AI when they are completing the ad copywriting task, whereas the treatment groups are assigned with 2 different modalities of using large language models when they write the ad copies. So in the end, we have a 3x2, between subject design. And to motivate our participants to exert their best effort when they generated ad copies, we implemented an outcome-based incentives where the better your ads perform, the more payment, the more bonus payment that you will get at the end of the study. So this ensures that our participants are properly motivated to actually put real efforts into the task. And to manipulate how the users engage with large language models using different modalities, we implemented a custom chat interface using the GPT-4 API. So this provides multiple benefits. One being our ability to directly embed this chat interface on the Qualtrics platform. And we can also retain the full chat log for textual analysis later. And the most important feature of this interface is the ability to manipulate the system prompts that we supply to the GPT-4 API. So in the ghostwriter group, we asked the LLM to only generate content for our participants, but never provide any feedback. Whereas for the sounding board modality, the large language models would refuse to provide any ad copies and only provide feedback for the participants. And we've done a lot of prompt engineering and testing. So we actually look into the chat log to find any potential violation where people in one group may be able to find a way around to use the large language model in another modality, and we did not find any evidence of that. So here's the overview of the experimental procedure. To make sure that our participants are familiar with the chat interface as well as the modality they are assigned with, they first are required to complete a familiarization task. So in the familiarization task, the participants were not required to write an ad copy, but nevertheless, they were given an example product, which is a tablet holder over here, to simulate the task structure. So here, all of the experimental groups, including the control groups, were required to engage with the ChatGPT-4 based chat interface by sending at least one message. So we do so to ensure that the fatigue level across all the treatment groups were exactly the same before they go into the main copywriting task. And for the control group, they get randomly assigned modalities for their chat interface. And to prevent our participants from using large language models or other AI outside of our experiment, the copy and paste function for the clipboard is restricted strictly within the web page so that the participants cannot transfer any information in or out of the web page, making it pointless to actually go out and use ChatGPT to complete the task. So after that, they go straight into the main copywriting task. So this is the task where they actually need to write an ad copy. So again, the participants here are reminded about the outcome-based incentives, and they all receive the same LM chat interface and get the assigned modality, of course, except for the control group. So here, all the treatment groups can engage with large language models as much or as little as they want, which simulates the real-world scenario where you can engage with ChatGPT at your own will. And before they finally submitted their ad copy, they got a chance to revise or edit their ad copies before the final submission. So after the participants submitted the ad copy, we take this ad copy and launch ad campaigns on Facebook and Instagram. So to prevent any retargeting effects, we assign a random county in the United States to each of the ad copy, and these counties, they all share the same, the similar demographic such as population and median income. All these ads have exactly the same ad budget, exactly the same ad configuration, exactly the same duration. To avoid any time-specific effects, these ads were run both on weekdays and weekends. So everything else being equal, we believe that the ad clicks should reflect the true quality of the ads. So before we jump into the main results, let's just quickly do a validation check. So we want to know whether experts are truly doing better than the non-experts and whether the ad clicks are reflective of the ad quality. So here we compare the experts and non-experts in the control group. And we find that experts does perform better than non-experts, meaning that our manipulation is successful and the ad clicks is reflective of the true quality. So let's get into the main results. So first, among non-experts, we found that the sounding board modality actually significantly increased the ad performance, but we did not find any significant effects for the ghostwriter group. However, among the experts, we did not find any significant effects in terms of the sounding board group, but we do find that their performance dropped significantly after using the ghostwriting modality. So the key insight here is that the benefits of large language models depends on the combination of the usage modality as well as the human's expertise level. So ghostwriter harms the experts, but sounding board benefits the non-experts. Now, we are curious about what's the underlying mechanisms that may be driving these nuanced effects. So here we rely on the text embeddings that we extracted from the final submitted ads, as well as the track history, to perform a textual analysis. So the first thing we do is to look at the originality of the sets. So we obtain all the text embeddings of the final submitted ads, and we calculate the semantic divergence, which is a very popular way of measuring how original or how creative the text is within a group. So here we calculate the cosine distance of each text embeddings with respect to its own centroid. So the higher the distance, the higher the originality. And here we find that compared to the control group, the sounding board group has a slightly lower originality, whereas the ghostwriter group has a much lower originality. So this is the first piece of evidence suggesting of the potential anchoring effects. And next, we want to have a more direct evidence of the anchoring effect. So what we do is that we look at the track history and extracted the first ever draft of the ad copy that's generated in the process of engaging with large language models. Using sounding board modality as the baseline, we find that the participants in the ghostwriting modality actually revise their ads throughout the process much less than the sounding board modality, which is a more direct evidence of the anchoring effects. And finally, we are curious about how does the non-experts gain such a significant boost from using the sounding board modality. Well, we then look at whether these non-experts are writing more like human experts. So to do so, this is our approach. First, we take the text embedding from the experts in the control group and calculate its centroid, which is the green dot over here. Then, we take this centroid and look at the non-experts across all the 3 treatment groups. And then we calculate the distance between these non-experts embeddings with respect to the expert embeddings in the control group. So these distances would reflect the distance, how different the non-experts and experts are in the experiment. So here we find that the distance is similar in the control group and the ghostwriter group, but for the sounding board group, we find that non-experts are much closer to the experts in the control group, meaning that if you use LLM as a sounding board group, non-experts actually learn to write more like experts in the control. So that also helps us to explain why we observe a slightly lower semantic divergence in the ghostwriter group in our first test, because if non-experts are writing more like experts, when you put them together, you would expect a lower group level divergence. So, to summarize, the benefits of large language models depends on both the modality and the expertise of the users in the context of creative tasks. Using large language models as the ghostwriter actually harms experts, making their ads less original and making them revise less, which is likely due to the anchoring effects. However, if you are using the large language models as a sounding board, non-experts benefit from it by learning to write more like experts. So that concludes my presentation. And by the way, in addition to the first example that I showed where you can utilize large language models to write emails for you, I have another tool that accommodates the sounding board modalities that you can download by scanning this QR code. It's also open source. So thank you, and open to questions.